Good evening. Um, I guess we should start now. Is my screen visible? Hello? Can someone tell me if my screen is visible?
Hello? Yeah, it's visible now.
Okay. So, good evening, one and all. Myself, Yashvi Sheth, and today it's the sixth session for Basic Environmental Engineering Pollution and Abatement. So, previously, so far, we have discussed, like in the last week, we covered about what is like how to prevent or what are the methods for sample collection and air pollution prevention. So now in this week we will be taking care of with water treatment. So basically what kind of water treatment we are interested in can be two types like the end usage is for drinking purpose. Okay. So first and foremost, naturally available source of water is nothing but groundwater and surface water. And nowadays, they also have certain levels of undesirable concentration. It cannot be very harmful pollutant, but the range in which it is permissible for drinking water, it can be above that level. So for example, groundwater and surface water, they like nowadays we use household water purifiers as well, which are able to purify these groundwater and surface water. And mainly for drinking purpose, we use groundwater. So now, depending on the type of pollutant present, there can be categories for treatment of water. So here for surface and groundwater, it seems that surface water tend to be more polluted because you can add more and more things to it.
Ma'am,
Yeah.
ma'am, your
Yes.
voice
Hello.
is not getting properly.
Acha, my voice is not clear.
Yeah.
Wait a minute. Am I audible to you?
Yeah.
Oh, yeah. So for surface water, these tend to be more polluted because anything you add in the environment they can end up in the surface water, while for groundwater there can be just the minerals or any sort of pollutant which is um, coming from surface water, or it is present in soil which is leached into groundwater. So this is comparatively less polluted, and more often we use groundwater for drinking purpose. Now, since surface water has, it can have plastics also, it can have some solid pollutants also in the form of like plastic bottles, in the form of flowers or any such thing. So in that case, you need a screen for that removal. Then there can be requirement like all these um, treatment technologies are subject to what kind of characteristics are present in that particular region. Now it can vary little bit, okay, for surface and groundwater, but for industry, we will talk later. It varies from industry to industry also. So for surface water, then we have for the small sized or coarse suspended particles, we have coagulation tank, which is followed by flocculation. Then we allow them to settle in the sedimentation, and further, if few fine particles are not removed in sedimentation, we remove it by filtration. And apart from that, if it is not much polluted or it is very little polluted, then depending on what pollutants are there, uh, we can have adsorption or such kind of tertiary treatment. And later, there can be obviously microbes present in it. So we disinfect the water to remove or kill the microbes. Now, similarly for groundwater, you can say that groundwater has mainly hardness. So in that case, the major treatment technology would be lime soda process, which is a treatment technology to remove hardness. Another way of removing hardness is ion exchange. I guess, yeah, it is covered here, so I will not go in detail. So yeah, so these are the steps, like which are similar to surface water, but just it does not require any screening or sedimentation of particles. Once you precipitate them, then only you provide sedimentation. Now, during lime soda process, there is change in the pH of water. That is why you add carbon dioxide to water so that the pH gets adjusted by recarbonation. So now if we look into the detail of each of these processes, so starting with surface water purification, first, as I said, screening is just to remove the major solids, say for example plastic, which are even clearly visible. Now, for coagulation and flocculation, these are for suspended solids. So in case of suspended solids, they will not be easily separated from water by using any strain, okay, or any screen. So in that case, what you do, uh, uh, coagulation is a method. Say for example, if this is the particle and it has majorly they are negatively charged. So due to both the particles having same charge, there will be some attractive forces which is dependent on the particle nature, like size dependent, and there is another electrostatic repulsion between the particles. So there will be a distance above which, like, they will not be able to come closer. So in that way they will form a stable suspension of particles. They will not be able to come closer further. Now, in coagulation, like since the particles are very small, in that case, to allow them to settle under gravity, it will be difficult. So in this case, what we do, we try to neutralize this charge which is existing on the surface of particle. Okay. So if we try to reduce the charge, then the attractive or intermolecular forces of attraction between two particles, it will increase, and hence the particles tend to form bigger particles. Okay, so coagulation is nothing but you just uh, uh, I will take a new slide. So coagulation is nothing but you just add a coagulant which is neutralizing the charge. Okay, you add the coagulant, you mix it, and then you allow it to go to a flocculation chamber or the vessel. Flocculation. Here you provide some gentle mixing so that the particles which are there, they come closer and form bigger particles. Now, these particles, if allowed to settle under gravity, they will further um, settle under gravity. So, next is, yeah, so majorly coagulants that are used are alum, ferric chloride, another salt, it can be ferrous sulfate as well. So, these are the kind of salts or compounds used for coagulation. Now, coagulation is performed, as I said, you provide just a few seconds of mixing, which is known as rapid mixer for coagulation. Okay. And now, if you are taking that water after addition of coagulation into a flocculator, it is usually of paddle flocculator type where you have a vessel and you provide baffles so that you there will be a mixer here. So due to slow motion of particles, they will try to and water will flow in this direction. Okay. So here the particles come closer and they form flokes. Now after this flocculator, it goes to a sedimentation tank. Okay. And once it goes here, here you provide gentle mixing and this bigger flokes that are formed, it is allowed to settle here and due to this tapered design, the settling will be more efficient. And you can combine all the three processes of coagulation, flocculation, and sedimentation in one unit to have a clary flocculator where all the three processes are combined. Now, for separation, after sedimentation, for separation of any tiny particles which are left, it can be done in sand filtration. And sand filtration has levels of different um, diameter or size of sand particles, which obstructs the passage of any um, tiny particles which are present in water. So this is how it works. Now coming further, if there is some more hardness which is present in surface water, then it can be removed by ion exchange. Now ion exchange can be of two types, cation exchange resin and it can be anion exchange. So cation exchange is usually to remove Ca2 plus and Mg2 plus. And if any of the anion is present in excess, then you can even have anion exchange resin. But majorly, ion exchange is used for Ca2 plus and Mg2 plus. So in that case, what we do, we take any salt like in the form of this. Now here this Na plus like Na is replaced by Ca. So what forms this R since Ca has two valencies. So this type of structure will be formed and here the Na will be replaced by calcium. So which means that ion exchange has occurred. Um, so you can say that since the concentration of calcium and magnesium will reduce in this manner and sodium is, you can say it is not that much harmful or It will not cause scaling. So in that case, calcium and magnesium will be removed and sodium will be added to water. Now further, for purification, if any sort of different complex molecules are present and they are not removed by this, then RO can be used. Now RO is a membrane which separates the molecules which are present in water. Now these are the pollutants present. Now the sizes of these pollutants is much more higher than the pore size. So RO is a kind of filter, okay? Now the size of pores is much smaller as compared to the size of pollutants. So in that case, the pollutants will not be able to pass through this um, filter. So this is how RO works. Can you tell me if you have seen any of the filter, like how its surface or how the pores look like? Have you seen that? Or do you know the mechanism, like uh, do you understand this? The difference in pore size which results in the separation of pollutant?
Can we consider micron filter in that
Yeah,
with
so
different like point 0.5 micron filters and like that?
the you must have heard of filter papers that you use in lab. Everyone would have used, right? So
Yeah.
filter paper would have pores which are much bigger. So in that case, if you have very big sized solid, then it will be easily removed and water will just pass through that. Now here in membrane filtration, what happens is the pores that are there. Now even in filter that you use in lab, the pores are not visible through your eyes, but you gradually keep on decreasing the pore size, and the sheet that, like, it will be just like plain paper, it will be similar to that. Like from naked eye you will not be able to see the pores, but the sizes are such that it will remove the pollutant. For example, if you have bacteria in water, then ultrafiltration will be used, and here the pore size is such that the bacteria is bigger than the pore size. So bacteria will be restrained from passing through, and that is how you purify the water. So what you see in lab by filtration, it is like you can see through naked eye. However, similar phenomena occurs of size exclusion, but you will not be able to see through your naked eye. I hope this clears you.
Yeah.
Okay. So next is disinfection. Um, So disinfection is nothing but to remove or kill all the microbes which are present in the form of bacteria, fungi, or virus. And for that, you can use chlorination or ozonation, where reactive species are formed, which efficiently kills the microbes. So the mechanism mainly is, if there is a bacteria, then the DNA of that bacteria will be ruptured, and so further growth will not be possible. So such type of killing mechanism is observed in by forming reactive species. uh, okay. So, as I said, for surface water, there will be more type of treatments required, whereas for groundwater, comparatively lesser will be required, because mainly it will have some hardness in the form of calcium and magnesium salts, and obviously bacteria will obviously there. So, in that case, you will use lime soda process, or Or if you want to remove it in your home also, then what you can do, you can have membranes also, which will remove or which will take care of both hardness and pathogens. Now, household filters are such that it takes care of mostly each and everything. It it is a series of filters where you can see that there will be sand filtration, then there will be activated carbon filtration. So it is specific for each and different type of pollutant. Say for example, activated carbon, it can absorb some amount of organics or few hazardous pollutant because groundwater has very trace of it. So in that case, it will absorb the trace level of pollutant. Now RO will be able to separate the ions which are present in water. So RO is obviously there in series with it. So this is how household filtration works. And mostly for groundwater, household filtration will be enough. Now moving forward, if you have industrial, uh, industrial or municipal wastewater, so this will be obviously in bulk quantities because whatever wastewater is coming out from your home also, then it goes to drainage and that drainage is um, having one local or one point where it is collected. So now once it is contaminated, you need to treat that water. Now, in that case, that municipal water or it is called as sewage water also. So firstly, where there is no chance that you can treat water, so it is on-site disposal is used. So here you can see that for on-site disposal, you have a septic tank where the inlet water comes from the source, and here you provide the baffles so that if there is some amount of solid, the motion of those solids will be uh, hindered, and in that case, they fall down. So, and the path of water flow is also changed so that there will be settling of the particles further. So this is how it works, and further the outlet, which is you can say that it is somewhat purified. You can send it to some groundwater where naturally there can be some kind of purification. Say, for example, if there are some organics, then it can absorb onto soil and so on. Now, another, as I said, is sewage water. So, sewage water mainly has, like, for example, you use um, surfactants, soap for cleaning. Then you have, say, for example, um, plastics, you whatever you add, like by mistake also. Then you can have uh, toilet waste. So all such type of waste will be there in sewage, and there can be some liquid which is coming out of food also. So all such kind of water will be taken care of in sewage treatment plant. So here mainly sewage treatment plant requires solid removal, uh, then requirement of organic removal because whatever waste which is coming from toilet or liquid from food like water from food waste or some sort of pesticides or insecticides which have been coated with vegetables, they also get washed away with water, and all such are organics. So in that case, majorly you need to take care of solid, like it can be coarse or it can be suspended. Both you need to take care of, and organics. Obviously, there can be bacteria because uh, toilet wastewater is also involved. So in that case, bacteria and other microorganisms they will be present. So obviously disinfection will be required. So if we talk about domestic and sewage treatment plants, so mainly preliminary treatment will take care of much coarse or say for example any sort of plastic waste or uh, flowers or any such sort of things they are present, then in that case they can be removed through preliminary treatment. Next is primary treatment where you remove suspended solids, and here you can say coagulation, flocculation, and sedimentation will take place. So it is a kind of primary method. Now, secondary method will have removal of such type of organics where you have decomposition or degradation of organics through some aerobic process. And later you have tertiary treatment where you try to kill the bacteria or any specific pollutant is present. In that case, you take tertiary treatment, which is, say, for example, disinfection. Okay. Now here, physicochemical treatment is just um, coagulation, flocculation, and sedimentation. And biological treatment is like if you want to classify further, then biological treatment is for organic degradation. However, if you club both of this, then it will be physicochemical biological treatment. So, yeah, this is like for municipal, you do flotation of coarse particles, then you do VOD removal in secondary process. Okay. Uh, yeah. So, if you then talk about industrial wastewater, then industry to industry wastewater, like you can say that for municipal wastewater, the quality will be more or less similar. However, for industrial wastewater, it varies with industry, and also in a particular industry, if it is operating in a batch mode, like from time to time, what you are manufacturing is different, then in that case, in within an industry also, the pollutant quality and quantity will vary. So what you do, many bigger industries, say for example Reliance, then in that case Reliance will have its own treatment plant for wastewater, which is nothing but effluent treatment plant. So they will have uh, its own treatment plant where they try to uh, treat the water which is polluted, and they try to recycle that water and reuse it. However, in the case where the industries are not self-sufficient to treat the pollutants, then in that case CTPs are used, which is nothing but common effluent treatment plant. So here, common effluent treatment plant is uh, used mainly for the industries which are operated at a very small scale, and they are not able to treat their own wastewater. So in that case, common effluent treatment plant will have common treatment technologies like all these preliminary, primary, secondary, and tertiary, which are used for domestic and industrial wastewater. They will be employed to remove and take care of all the pollutants which are present. So, yeah, starting with the primary treatment equipments, you can say that for primary treatment, mainly coarse particles they are removed by bar screens. So here you can see the image of bar screen where the path of the particles is obstructed and they are bigger enough or big enough that it will not be able to pass further. Now, for somewhat smaller particles, Great chamber is provided. Great can be in the form of sand, clay, etc. So if they are present, then in that case, what you provide a long and narrow um, water flow channel where water flows slowly and some amount of these particles they are settled. Now further these water passes through to equalization tank. Now can anyone tell me why is equalization tank like which is a major equipment or required in industries?
Ma'am, to remove oil and scum.
No, I am talking about equalization. There is some hint in the name itself, so you can guess
Maintain the
based on.
pH.
So yeah, you can like pH is obviously pH is one such parameter, but it is not the only parameter. So equalization tank is to maintain equal concentration every time. So for example, I gave you an example of CETP where wastewater comes from multiple industries. And you can say that if they are operated in batch, then the pollutant, which is the concentration of pollutant, the type of pollutant, they will vary with time. Okay. So in that case, also the flow rate or the amount of wastewater which is released by industry, they will also vary. So in that case, you can say concentration of pollutant is different. Cons Flow rate of water is different. They both are different. So concentration in it can be, as you said, it can be pH of water. It can be organic concentration. It can be heavy metal concentration. So it can be anything. So any sort of pollutant, it can have varied concentration. So now if such variable concentration, such variable flow rate is passed to further treatment units, then what happens? The efficiency which you want to maintain, it will not be maintained because sometimes you will have much higher flow rate. Then in that case, not all pollutant will be removed. So load will be more obviously for the pollutant. So in that case, whatever like you cannot change the design of any unit. Okay, once it is done. So for that to minimize the fluctuation in the efficiency which is obtained, you have an equalization tank. So you have one tank where you just mix the water to minimize the fluctuations. So here it is just a mixer, and you take the overflow which is further processed. So now here um, the fluctuation in concentration of pollutant and flow rate, they are minimized. Okay. So now this is the main usage of equalization tank. Now if you check for sedimentation tank, then sedimentation is usually done after coagulation and flocculation. So in the case of sedimentation tank, the bigger the particles, they will settle very easily. Obviously, if they have higher density or much more denser than water, then obviously they will tend to settle faster. Apart from this, temperature gradients and turbulence also plays an important role. Like for example, is if water is it is having much turbulence, then in that case, settling will be less. Okay. So what you do? There are types of settling which is observed. Here you can see in the image. For example, if you have suspended particles, someone is not mute. Can you please mute? Yeah, thank you. So, if the particles are very less, then they do without interacting with each other, they tend to settle under gravity based on what settling force they are experiencing. So there is no interaction. Now, type 2 is somewhat higher concentration, but also in this case, you can like you can say this is free settling. Somewhat higher concentration, but still you can neglect the interaction. However, this is hindered settling where particle concentration is much higher and interaction has increased such that they will um, affect the settling velocity and affect the settling um, of each other. So this is nothing but hindered settling. And last is nothing but if some of the particles have already settled and formed a cake, then whatever settling further will occur, that will nothing but be because of the compaction, like the forces that particles exert. So that this is nothing but compaction. So it will reduce the width or the like if this is right now, then it can happen that same quantity of mass has come to this level. So it is nothing but compaction. So depending on the type and the concentration of these type of particles, you need to design sedimentation tank. Now, another type, various types of sedimentation tanks like hopper type or circular tanks, rectangular tanks, they have been discussed in the class. I'm not going in detail. So another is dissolved air flotation. So if this is the water tank, what you do, you try to pass the air from the bottom and the bubbles will allow the particles to stick on it. This is the bubble. Okay, and since air has lesser density, so it will tend to move upward in the upward direction in the from the water bulk water surface to the topmost surface. So what they will be collected here, like the particles will be collected here, and they can be removed from the surface. Now moving forward, uh, talking about secondary treatment method. So secondary treatment mainly deals with oxidation. So now mainly oxidation of organics needs to be taken care of, where it can be done in the presence of oxygen and in the absence of oxygen. So deciding whether to choose aerobic process or anaerobic process, it depends on various factors. Say for example, proper source of oxygen or proper source of air or such thing is not available, then in that case you can use anaerobic. Also, it depends on the type of pollutant or the organics which are present because some type of microbes have more sensitivity to some type of organics. So in that case, there are various factors based on which you decide whether to go for aerobic or anaerobic process. Also, if there are chances that, like from anaerobic process and from aerobic process, here you generate CO2 and H2O because organics have, it can have further sulfur, say for example, or nitrogen. Now, all this will be oxidized to end product. So, CO2 and H2O will be the major product here. However, in anaerobic process, CH4 and CO2 will be produced. So in this case, you can use CH4 as biogas and you can generate energy. So this type, depending on these factors, you can select whether to go for aerobic or anaerobic process. So now moving to aerobic process, uh, no, sorry, moving to conventional treatment process, it can be lagoons, it can be aerobic digestion, for example, activated sludge process. Then it can be anaerobic digestion also. There can be biofilters also. And some of the advanced methods, like these are all conventional, which are nowadays used in industries. However, the conventional can be membrane bioreactors, phytoremediation, granular activated sludge process, where you provide more surface and simultaneous removal by multiple mechanisms. So, um for both aerobic and anaerobic process, you can have two types of microbial distribution inside water. So it can be uniformly distributed in water, or you can provide a surface where you have a layer of bacteria or where you adhere the bacteria. So those are nothing but biofilters. So you can attach growth is nothing but biofilters. So suspended growth will have lagoons. It can have aerobic digestions in the form of activated sludge process. It can be anaerobic digestion also. So lagoon, talking about lagoon. So it is nothing but you allow the water to undergo oxidation process under, if this is the pond, then you allow to interact with the atmosphere and whatever natural microbes present, they will cause degradation. So it is all natural process. Now, in case of activated sludge process, the amount of bacteria or microbes that are used, they are in much in excessive quantity, and also you provide externally some amount of stirring, as well as you provide external air supply. So this, say for example, this is the tank. So there can be diffused air, air diffusers in the bottom. So bubbles will be sprayed. So these are air diffusers which will cause bubbling of air. So it will also cause turbulence inside it, and microbes will be present. So as the air bubbles come in contact or oxygen come in contact with microbes, they will utilize the organics to take the nutrient and for further growth. Now it again goes to sedimentation tank where the sludge of this microbes, there will be some amount of live bacteria, some amount of dead bacteria. So you do not waste it all at a time. So you recycle some amount of, this is fresh and this is recycle. So you recycle some amount of microbes, or you can say sludge. So this is how it works. Also for the growth of microbes here in the activated sludge process, there will be some requirement of nutrients also. So those nutrients or the amount of nutrients in the water is taken care of, and you provide it externally if it is not present. Here it is treated water. Now moving forward, anaerobic digestion, as I said, it will be uh, in the absence of oxygen. Here, in activated sludge process, since it is aerobic digestion, it is open to atmosphere. Now, in anaerobic digestion, you need to have a closed chamber where water will be present, and in the absence of oxygen, the microbes will degrade the organics. Now, this can further be connected to some biogas plant, okay, for energy generation. Now, talking about uh, biofilters, as I said, you provide a fixed surface for bacteria, so it can be in the form of trickling filters, where uh, if you have some sort of packing here, then water is sprayed. These are nozzles. So you spray the water on this surface, and microbes will be attached here, and you provide proper contact time so that as the water falls, they will try to degrade it. Now there can be rotating bed also, where you have a pool of water and there will be a submerged rotor, and it will have bacteria. So when it comes in contact with atmosphere, it will have oxygen, and when it comes in contact with water, it will contact with organic. So this is how. Uh, Now this will keep on rotating, which will uh, uh, have the excess of microbes, which both organics and atmosphere for air for degradation. So this is all about bag filters. Now, you can say that bacteria, like for the growth of bacteria, this is dx by dt, which represents growth of bacteria, because you need bacteria to grow by consuming organics. So, this rate should be positive, or more and more rate is required. So, for that, you can say that there will be some amount of bacteria which is generated at a time, which is defined as this mu x, and there is some amount of bacteria will be which will be killed also, depending on the uh, characteristic or water characteristics of water, or natural death. So in that case, this is the death rate. So amount or net amount of bacteria which will be present or changing in water with respect to time is nothing but dx by dt, where X is the concentration of microbe per unit time, which is growth minus decay. Now, this growth will depend on the substrate or the organic which is present. So, more the substrate utilization rate, or you can relate the growth of bacteria with substrate utilization rate by a factor or yield factor called Y, which is nothing but yield, like what amount of substrate it is utilized and to form what amount of bacteria. So that ratio is nothing but Y, yield. Now this mu here is a constant which is denoted as monod function, and this constant is uh, representing decay and growth of bacteria. So this is how it is represented. Now S is the concentration of substrate here. So yeah, this is how it is a differential equation which needs to be solved. And by using mu, you can say that growth of bacteria depends on the concentration of substrate as well. Now, also for providing proper efficiency, you need to have certain amount of detention time or residence time inside the tank. So detention time or residence time is nothing but uh, T equals to, or T or tau is volume per unit flow rate. So volume will be in liter, say for example, uh, liter, and if this is in liter per minute, then detention time will be in minutes. So you can, according to the unit, you can find the detention time. I hope it is clear so far. Then I will move to the assignment. Okay, so I'll move to assignment. Which of the following option appropriately connects the treatment device with the treatment limitation? So one is activated carbon filter, another is ion exchange, and third one is reverse osmosis. So activated carbon is based on surface adsorption. So it will not be able to absorb bacteria and nitrates. So for activated carbon, you have three as the
Third.
correct answer. Yeah. So ion exchange, if you look into the options, if the water has oxidized iron or iron bacteria, it becomes clogged or lose its softening ability. So two is the correct answer because what we do by ion exchange, we remove hardness or which is nothing but softening of water. And last is reverse osmosis. So this is the only option left. So it will like since it depends on the size of particles or pollutant. There can be some pollutant which has very small size as compared to the pores also. So you can say that not all can be removed by reverse osmosis. So now moving forward, a process of aggregation or accumulation of colloidal particles to settle down as a precipitate is known as dash.
Coagulation.
Yeah, coagulation. So it allows to aggregate the particle which are in suspension form, which is nothing but coagulation. So basically, I have told you the mechanism where it reduces the surface charge and allows the particle to come closer and form bigger particle. Now, next is identify the missing steps in the following depiction of surface water treatment. So here A is, you can say, it is nothing but clariflocculator because here what you are doing, you are simultaneously remove providing baffles, which is for flocculation. You have added mixer, which means it is required for mixing the coagulant. It is required for sedimentation also, sedimentation tank, and the tank shape is similar to sedimentation. So this is nothing but clariflocculator. And further, this is nothing but a sand filter. You can see here, this is the layers of sand which is represented by this, as it is shown in the slides by professor. So this is the sand filter. It is clear, right?
Yeah.
Next is reverse osmosis method of wastewater treatment is a part of which kind of treatment? So it is nothing but a
Tertiary.
tertiary tree. Yeah. So tertiary treatment, you can say that it is involving some specific pollutants. So it takes care of any specific pollutant which is present, and all these processes are generalized processes. So you can say that tertiary treatment is specific process. Next is solids such as sand, bone, chips, seeds, coffee grounds, large organic particles such as food waste, eggshell can be efficiently settled from the polluted water with the help of dash.
Great chamber.
Yeah, Great chamber is the correct answer, and all this can be classified as greets only. Like greet is the classification for these type of pollutant. Next is identify the figure given below. So This is the kind of sedimentation tank, and from that you need to identify which kind of tank it is. So, such tapered uh,
Hopper bottom turn,
yeah,
I guess.
so it is a hopper bottom because otherwise, uh, in other types, you can have sludge collection from the bottom as well. So this is hopper bottom. Next question is for the secondary treatment process of water. What is the difference between aerobic and anaerobic process? So aerobic is obviously which occurs in the presence of water, and anaerobic is the one which occurs in the absence of water. So, yeah, option
B.
yeah, B is the correct answer. And these are the type of bacteria or microbes which are used for aerobic and anaerobic activity. So now this is the question. A drinking water treatment plant uses circular sedimentation basin to treat 5 mgd of river water. So here mgd stands for million gallons per day, and you have been given the conversion also to meter cube per second. So here, sorry, Q is given to you as 5 mgd. So if you convert it into meter cube per second, so it will be 5 into 0.0438 meter cube per second. Okay. Now next is the plant clarifier is deep 5.5 meter deep, and it has 15.5 meter diameter. So you can say that if this is the tank, diameter is 15 meter and depth is 5.5 meter. Water is at 15 degrees Celsius. The water density and viscosity at this parameter at 15 degrees Celsius is given as this. What is the hydraulic detention time? So for hydraulic detention time, you do not need the any of these parameters. It is nothing but volume per unit flow rate. Make sure the units are consistent. So considering this clarifier as cylindrical, so you can say that the volume of this tank will be nothing but pi r square h, or you can say pi d square by 4 h. Here d is the diameter and h is the depth, you can say. So if you put everything, 3.14 into diameter is 15 square into h is 5.5 divided by 4, and flow rate you are given as 5 into 0.0438 meter cube per second, and this is in meter cube volume. So time, whatever it will come out, it will be in seconds. So can you calculate that? And you can see that options that are obtained, it is in hours. So to get it in hour, so you need to divide by 3600, whatever seconds you are getting. So seconds per hour. So that will be the time in hour. Is it clear?
1.23.
Yeah, 1.23 is the correct answer. I guess all the conversion steps are clear. Is it clear?
Yeah.
Okay. So next question is the circular sedimentation tank fitted with mechanical sludge removal unit is to treat 5 million liters of water per day. So here flow rate is given to you as 5 million. So 1 million is 10 raised to 6, okay, and liters per day. Now the detention time of the tank is T is 5 hours. If the depth of tank is restricted to be depth is 3 meter, sorry, depth is represented by h. So h is here given to you as 3 meter. Calculate the diameter d of the tank. So the same formula will be applied here. We just need to have unit consistency. So here volume is in liters. So you can say that 5 into 10 to the power 6 liters. If you want to convert that into meters, meter cube, so you need to divide it by 10 to the power 3 meter cube. Now this time is in day. Okay. So if you say 1 day will have
24
24
hours.
hours. Okay. So you need to multiply it with 24. Yeah. So this you will, if you do the calculation, then you will get a flow rate. Now the units are consistent. Everything is in meter and hour. Now if you substitute, then T equals to V by Q. And so volume is nothing but T into Q. Now volume or the capacity of tank to you here is given as some formula d square 0.11 plus 0.785 h, that is equal to T is 5 hours into Q is 5 into 10 to the power 6 divided by 10 cube by 24. Put up the value of H as well here. So it will be d square 0.11 plus 0.785 into 3, and you solve right hand side. So if you take this in the denominator, you will get the value of d square, which will be, please calculate that. And for calculating d, you need to take square root of whatever you are getting. So the answer should come as 20.59 meter. Are you able to calculate? So here d square is coming to me as 422.58. Is everyone getting this? And that is how, if you take the square root of 422.58, it will come to me as 20.55. Can someone please tell me if you are following or not?
खुद गड़बड़ है.
Sorry?
Calculation error.
Acha, you are having calculation error.
Yeah.
Wait, I will write the values of each and every thing. So 5 into 5. So this RHS term is coming to me as 1041.66. Okay. And this d square, so if I multiply this, then d square into it will come to me as 2.465. Now, if you divide 1041.66 by 2.46, then it will come out as 422.58, and further on taking square root, it will come as 20.55.
Yeah, got it.
Okay. Uh, Everyone else getting me? Yeah, so let's move to the next question. For a continuous flow settling tank, 3 meter deep. So here also, yeah, H is to you given to you as 3 meter, and length is given to you as 90 meter. So this is 90 meter, and this is 3 meters. Now, what would be the flow velocity of water for effective removal of 0.025 mm particles at 25 degrees Celsius, and specific gravity of particle is given to you as 2.65, and kinematic viscosity is given to you as 0.01 centimeter square per second. So here you can say that a particle will have horizontal component of velocity and vertical component of velocity, which you can say that for complete removal of this much sized particle, you need to have settling velocity corresponding to this particle, because otherwise if the particles are bigger than that, then obviously they will have higher settling velocity and they will be removed. Okay, so first thing is to find out settling velocity. Now for settling, you can say that the ratio here, uh, or the time taken by particle to settle at the lower most end here, then vertical distance that will be traveled for vertical distance, and for horizontal distance it should be same. So for vertical distance, you can say that velocity is nothing but distance per unit time. So time is nothing but distance per unit velocity. So here vertically the distance traveled is h, sorry, h by Vs, which is settling velocity, and horizontally the distance traveled is L, which is length, divided by horizontal velocity Vh. Okay, so to find out Vh, you need to calculate L by Vs into h, and here L and h are given to you where Vs is not given. So first step for you is to calculate Vs, which is settling velocity.
To calculate VH, L should be multiplied by with VS, na?
Sorry.
To
Uh-huh.
calculate
Yes.
VH,
VH will go this side. V in Yeah. Sorry.
H will come in denominator.
Yeah. Sorry. So VH equals to L into VS by H, right?
Yeah.
Now VS has formula. Uh, mm, it is G rho S minus rho dP square and 18 mu. Here mu is dynamic viscosity, and what viscosity given to you is kinematic viscosity. So here there is a correlation between dynamic and kinematic viscosity. So mu is nothing but mu kinematic into density. Okay. So if you multiply this, then it will be 0.01. This is in centimeter square per second. and this is 1 gram per centimeter cube. Then what remains is 0.01 centimeters, sorry, gram per centimeter second. Okay. Now to convert, uh, you need to check what units are required to you. So based on that, you can have a correction. So it's better if you convert in SI because here the units are jumbled. So 0.01, 1 gram is how much kg? So 10 to the power minus 3 kg. Okay. Then 1 centimeter is equals to 10 to the power minus 2 meter. Okay. And let's keep second in it, that only. So it will come to you as 0.001 kg per meter second. Okay, this is in SI unit, which is mu. Now, let me take a new slide. Here, further to calculate Vs, you need everything is given to you now. It is rho s minus rho dp square by 18 mu. Okay, now if you put up the value, G is 9.81. Rho s is given to you in the form of specific gravity, which is 2.65. Now, specific gravity is usually with respect to water, and here the density of water is given to you as 1 gram per
One.
cc, which is 1000 kg per meter cube. Okay, so in SI, if you multiply this with density of water, it will come out as 2650 density of particle kg per meter cube. Subtract density of water from it, 1000 kg per meter cube. Okay. And now dp. dp is given to you as 0.025 mm. Okay. So 0.025. Now if we convert this in meter, 10 to the power minus 3 square divided by 18. Mu is 0.001. Now if solve this to get Vs, this will be in meter per second. What are you getting? You should get
One triple
0.
zero five.
Yeah, 0.00056. Okay, I'm getting that.
Yeah.
Now, VH is what we have
L
derived,
into Vs.
L
L
into
into
Vs by
Vs divided
H.
by H.
Yeah, so if we substitute each and every value, then
L is 90.
90, Vs is 0.0056, H is 3, right?
3.
So
Yeah.
substitute this, you will get 0.0168 meter per second. Now the answer required is in centimeter per second. Okay, so convert this in centimeter per second by dividing by multiplying by 100 because 1 meter is 100
100 centimeter.
centimeter, right? So if you multiply, then it will come as 1.68
1.68.
centimeters. Yeah, is it clear?
Yeah.
Okay, so that's it from my side today. Do you have any doubt further?
Not till now. We will have some other questions in our assignment.
Okay. Yeah, you can do your assignment and like for this week, I will not be able to solve week six assignment because you have to do it on your own. But in the next class, if you have any doubt, you can come up with that doubt. Okay, so if not, then I will end this session today. Thank you, everyone. Thank
Yeah,
you for
happy
joining.
Teachers Day.
Thank you. So, thank you, everyone.
Thank you. Have a good day.